Today we are going to be talking about solving problems with SUVAT equations. And the cool thing is that you can use these equations in order to solve problems that are dealing with falling objects or objects that are thrown. There are three kinds of questions that deal with free fall. They are either objects that are dropped from a height, objects that are thrown with some velocity, and that could either be up and down, objects that are thrown with some velocity at an angle, which is called projectiles. Today's video is going to be over number 1 and number 2. So you remember these, right? These are the equations of motion, and we're getting pretty familiar with them, and the nice thing is we get to use them for falling objects. Let's begin our T-notes. When you have a free falling object, an object that is dropped from a height, so it's going vertical, the first step that you want to do is to draw a diagram. Step 2 is to list what you have. Number 3 is to highlight what you need. And then finally, you want to pick the equation that you need before you solve. One thing to note is that the acceleration is not going to be any different because the acceleration will always be due to gravity, which is a constant of 9.81 meters per second. Here's an example. A ball is dropped from rest. At one point in free fall, it has a velocity of 10 meters per second. Sometime later, it has a velocity of 23 meters per second. How long has passed between this increase in velocity? Step 1 is to draw a diagram. Here is our person with their ball. Here's the direction that the object is going to go. Here is what we know. And we want to know the time that elapsed between these 2 points. Step 2 is to list the variables that you have. Here's what we have. We have the displacement. We're not sure what that is. We know the initial and the final velocities for that specific range of time. The acceleration is going to be positive because it is pulling down towards the Earth, so it will have a positive value of 9.81 meters per second squared. The time is what we want to find. Highlight what you need, which is the time. Step 4 is to pick the equation that you need. Here are our variables that we know, and we want to choose something that will have UVAT. Let's look over here. And it is this equation here. All you need to do is plug in everything, and when you do that, you should get an answer of t equals 1.325 seconds or 1.3 seconds. Example 2, a ball is dropped from rest. What will the velocity of the ball be after it has dropped 30 meters? Draw a picture, a diagram for step 1. Here is my person with their object. And here is what we know. We were only given 30 meters for the distance. We don't know the v, which is what we want to find, but we can tell that because it is at rest that the initial velocity was 0 meters per second. So let's go ahead and go to step 2. Let's list the variables, and we were given these variables, and we want to solve for velocity after 30 meters. We also do know that because the ball is being dropped vertically, it is going down. It is under the influence of gravity, therefore it is a positive 9.81 meters per second. Step 4 is to select an equation given your variables. So we need V for sure. We have S, U, V, A. What could I use over here? Here we go, S, U, V, A. Go ahead and plug this all in, and your answer should be 24.26 meters per second, and that is your velocity after the ball has traveled between these two, from 0, from rest, to 30 meters. Objects that are thrown with velocity is, for example, if a person has an object and throws it up vertically and watches it come back down. So, in these examples, you want to draw a diagram, list what you have, remembering that gravity is negative when the object is going up, and then positive on the way down. You want to highlight what you need, pick the equation, and then solve. An example is that a ball is thrown upward with a velocity of 10 meters per second. There are two questions here that you want to try to answer. How long does it take to reach its point of maximum displacement? What is its maximum displacement? Step 1 is to draw a diagram. Here is my person with their ball, and they throw it upwards with these variables. So we know that the initial velocity was 10 meters per second, and at the top of its travel, it's going to have a velocity of 0 meters per second, because now it's going to be accelerating down and its velocity will be going in the opposite direction that it originally started. We don't know the time and we don't know the displacement, but we do want to figure that out. So let's begin. Step 2 is to list the variables that you have. Here's what we have, and because the ball is going up, it is negative 9.8 meters per second squared. We want to find t. Eventually we will find s. But for right now, we're going to disregard that one and just focus on finding an equation that has UVAT. Here is the one that we're going to choose, and then we just plug it in, we solve, and we should get an answer of 1.02 seconds, which is equivalent to about 1 second after the significant figures. Its maximum displacement, you would just want to pick the equation that you need. So here's what we have. And if we can find something with SUVA, that'd be great. And here it is. Plug it in, and this is what we have. Your answer should be that the displacement is 5 meters. That is your answer. Example 2. A ball is thrown upwards with a velocity of 20 meters per second. How long does it take to get back to the point that it started? Step 1, draw the diagram. Here's my person with their ball, throwing it up with a velocity of 20 meters per second. And we know that when it gets to the top, its velocity is 0. And then, of course, on the other side, we're looking at it from two different steps, on the upward motion and then the downward motion. We don't know the velocity at the end, and we don't know the time and the displacement on either side. So what we're going to do is begin on the left side, since we have one data point that we can play with. So let's go ahead and solve the upward info first. List the variables for the upward motion. Here we have negative 9.81 meters per second squared for the acceleration on the way up for the object. And we are going to solve for time. Pick the equation that you need, which would be UVAT. So it should be this equation here. Plug everything in, and your answer should be t equals 2 seconds for the upward motion. Next, we can solve for the displacement, which is the distance that the ball traveled on the way up. So let's find the equation. We're looking for SUVA, which would be the third equation. Plug everything in, and you should get an answer of a displacement of 20 meters. Now, one thing that we know is that the way up traveled should be the same distance down. So we know that the displacement for the way up is the same as the way down. Now let's solve t for the downward motion. We know that 20 meters is the s. We also have 0 being the initial velocity. We don't know the velocity on the way down, but we do have a positive 9.81 meters per second squared for the acceleration, and we're going to solve for the time. So let's choose an equation that will have t in it, and that also has some other information. So let's go ahead and use SUTA. Okay, so we had S, U, T, and A. Plugging everything in, you should get an answer of, after you round things, 2 seconds. So did you notice anything weird about the time up versus the time down? 2 seconds on the way up, 2 seconds on the way down. Well, we just did all this mathematical fun, right, to prove that the way up the time that it took for an object to travel on its way up is the same as the time that it takes for the object to travel on its way down. So if you ever run into another problem where it asks you how much time does it take for the object to travel on its way down, if you find it once, it is the same answer on both sides. All right, we've made it to the end of our T-notes, and let me just recap this for you. So we've learned that with the SUVAT equations, we can use these for uniform acceleration for objects that are falling. And we also did learn that the gravity is positive or negative depending on which direction the object is traveling. If it is going down towards the ground, it is a positive 9.81 meters per second, and if it is going upwards in its motion, it is a negative constant. We also learned that the time that an object travels is equivalent, the time that an object travels up is equivalent to the time that it travels down from the beginning to the end point. All right, so that's it. Be ready to use this information in class.